We are live. We're there now. I'm frustrated because my stream itself is good. It's not blurry. But what you're seeing is blurry. And that's frustrating. So now I'm trying to see if there's a thing here. You're on mute again, Damien, by the way. Oh, I'm live now. Should be able to raid. What's up with the cameras? Why are they not? Like, fam, what's going on? Here we go. Oh, because you don't have your camera on. So it's like, it's just saying like there's nothing there, which makes sense. Okay. Zoom, what are we doing? Come on now. All right. I'm not a fan of the, everyone that's watching, what's up, but also, hey, thank you for the follows and stuff. Everyone that's watching is, I think, y'all tell me in the chat if the screen is blurry or not, because it is showing up blurry for Damien, which is most unfortunate.
It's
you say it's fine until your eyes hurt later. But I'm wondering if it's like a Zoom setting thing. I wonder if it's like the Zoom calls.
The screen share.
I wonder if it's just like the default resolution of the Zoom call is like something goofy. Screen share, full screen mode, maintain current size, maximize windows side by side, automatically share desktop. I just want to make sure that it's my camera. Stop my video when presenting. All right. I'm gonna zoom in on this just to make it. Oh, that's the wrong way. At least make it a little bit easier for your eyes.
I'm also on the stream, so I can just look.
Okay, cool. Yeah, the T-Mux is supposed to have styling and it's not, so I don't know why it's. That's the thing I'm figuring out. I'm playing around with a bunch of stuff. So we've done some stuff here. We've made I've made this thing called J Plays with Classes, and then we have this file called class because why not? Why would you not have a class? So let's do wrong way, sir. There we go. So we'll have these side by side. We'll do that, and then let's talk about classes, right? That's what we're here to learn about. Oh, I'm not in J Plays with Classes yet. There we go. Okay. So, what if I told you that a class was effectively like these things are objects, everything is object is life. When we talk about things being classes, what we're talking about are these objects in Python that we can define And in those definitions, we can then say they do things. They do things many different ways, not just doing things from the realm of like, you know what? Why am I trying to be philosophical about this? Let's just write some classes, right? All right. So the way that you write a class is you basically class and then whatever your class is. We're going to talk about a car, right? This is a very common lesson. Oh, see? So common, in which Copilot decided to do all the things for us. We're going to first disable Copilot. Okay. Which is going to help. There we go. All right, so we've got our car class here. Now, many blueprints towards one goal. I like it. So when you think about a class, you think about it in terms of two things: what it has and what it does. So what does a car have?
Like what parts can make a car?
Yeah, what are the parts that make a car?
Wheels.
Okay. And we'll figure that out in a second. What is this? No. Just any. Just any. There we go. Okay, what else do they have?
Body. I assume we're doing like a large thing. We're not trying to get really intricate.
Yeah.
Chassis, that's the name of it.
Okay, anything else?
Windows.
Okay. One more.
One more. An engine.
Okay, perfect. I like that. Okay. So right now we're saying that these can be anything and they're things. So at the end of the day, and also the type hinting is not necessary. Depending on how far we get, the type hinting will become necessary again, but for now it's not necessary. We're doing this because I want you to understand that these values can be anything. In fact,
Okay.
if I wanted to call a car, I would create what's called an instance of a car. So we'll say Damien's car is equal to car, right?
Mm-hmm.
Actually, missing something there. Car. And then we could then go in and start defining your car. We could say Damien's car dot wheels. There's 4 of them, you know, and then Damien's car dot chassis is upgraded model. We'll just say model LS, because sure, that's what you got.
Sure.
And then Windows tinted.
Yes. Arizona, baby.
And engine is
Ford F-150.
oh geez, Hemi.
You
Whatever.
know, it's like a V6, I think.
Okay, I don't know. Chevy are the ones that have Hemis in them, aren't they? I don't know. I don't do cars.
I don't do trucks.
I have
I'm a motorcycle person.
V6. Oh, we'll get there. Okay, V6, 1.8 liter. Sure, because that's a thing. I don't know.
Yeah.
Maybe it is.
I think that's literally what
That
I have
seems-
in the vehicle.
Yeah. All right. So we would define your car, and we could say now we want to print Damien's car wheels, and we'll say we'll do this. We'll say F string
Strings.
Damien's car has wheels, right? So now when we run that,
Okay.
so now when we run that, let's just see CDJ plays with classes. Oh, don't run it twice now. Yeah, Damien's car has 4 wheels. Why does it have four wheels? Because we defined it having four wheels. So this is a very loose construction of what you're doing here, of creating a class. Now, in this, we could go,
Mm-hmm.
I like to do watch TN1 Python file on the other window. I get what you're saying here. You're doing the watch Python file. I don't have watch. What is watch? It's like, what is this watch thing you speak of? I'm guessing it's like a file watch thing. Yeah. I just want to make sure executes program periodically, showing the output on the screen. Okay. Yeah, I just do. By the way, the answer to your question better explains conditions and maybe loops. That's what we were talking about before. When I was like, we've talked about this before. I get what you're saying. Brew install watch. This is actually kind of this is a neat little thing. Thank you for the tip. You're making me a better streamer. I love it. All right, so then we're gonna watch. What is the minus TN1? That's Tennessee #1. I love it. It's a Knoxville fan. Yeah. Go Balls.
Car. Oh, okay, that's why.
So now it's gonna say. Oh, it runs the command every second and shows the result. Gotcha. This is called J creates a memory leak. So now we have this whole engine thing that returns but here's the thing in classes. You have to define what the object is being acted upon, what the method is being acted upon. Here's one of these goofy things that happens in Python. Because we're talking about a class, we actually change the name of the function. We're not talking about variables anymore. We're talking about attributes. We're not running functions. We're running methods. When you say attribute, it means you're talking about a class. When you say method, it means you're talking about a function that's inside of a class. So this function in here is actually going to be now called a method. You have to tell the method what it's being ran on. It's being run on itself. So this is kind of an important thing. I've always seen that be self. I've never seen it be anything else. I've seen some fun stuff with that. I've written some fun stuff with that. But for the most part, as you're writing a class, you'll just define self as always being the first thing that you load in this. So now we could do this, and then we can print another thing. Damien's car says
pontificating. Check what this dang dog is.
Something like that, right? And we save that. Oh.
Okay. I'll be right back, Jay. I have to let the dog in.
Okay. We'll clean this up over here. Why can I not type today? Engine sound. Okay. Well, it's gone. We'll say Damien's car has an So interesting. We're gonna level this up quickly.
Sorry about that. I don't want his little brain to melt in the Arizona
Oh,
weather.
you're good. So all we've done in this is go in. Why do I have? Oh, zoom window smaller. There we go. So I have this in here where we've basically said Damien's car has an engine that goes engine sound. Engine sound is over here in the corner. Yep. Right? So we're calling the method. Now, this is great because we can create as many cars as we want. We're going to create a second car, but in just a second. But what we're going to first do is defining it like this is kind of gross. I don't like that. So what if every time we created a new car, we had to tell it the things that we were looking for? So for instance, the way that we would do that is we would create an initializer. And that is the first of the magic methods that we will talk about, which is def init. So
Sorry, now I'm only gonna be able to think of the UK every single time I think of an initializer.
init, yep.
Can you stop trying to lick my toes, you weirdo? Thank you.
Oh man, that's gonna sound great on stream.
Sorry.
All right. So now what's happened is I've basically said whenever we create this class, I want you to print ain't it, or we could say, you know, something like that. So we don't actually have to, this function runs automatically. That's why it shows up in our little window here. We don't ever have to manually call init. Whenever we create our instance of this car object, we just print that. Now, again, that could be useful. Maybe we could do, I don't know, a new car is rolling off the lot or something like that, you know, whatever. But what I'd like to do instead is start assigning these values when we initialize them. So that's when we can go, it's going to take, we're going to do this because I want us to be able to, do you remember what that star does, by the way? The star by itself?
It makes it so anything after it needs to be actually written in or assigned.
Correct. Good job.
I don't remember the name of the star though. That's the issue.
The error message is telling you it's missing 4 required keyword only arguments, which means you have to call the keyword to actually run the thing. So now here's why we call self. Self will start defining those values. So if we can say self.wheels, which will say the wheels are equal to this. Oh, someone was saying they're at work right now, but we're giving them a breakthrough in what they need. Hey, awesome! I'm glad that we were able to start working on this, or start helping you out on your journey. Appreciate that. All right, so we can say that, you know, self wheels are equal to the wheels that we'll define. But you might be saying, Jay, we haven't defined wheels in here when we create Damien's car. We haven't said wheels. Well, now we're going to. Wheels equal 4, right? So we can get rid of that line. And we got to do the other ones too. So we'll say self chassis equals chassis. We'll say self windows equal windows. And
so in a non-philosophical way, self is just the actualization of whatever you're defining.
Yeah.
Okay.
So we got wheels. Chassis is, what was the chassis? Model LS. Cool. Yeah. Was it Windows equals tinted and engine equals, what did I say? V6 1.
It was a V6 1.8 liter.
Yeah, something like that. And we get rid of all that. And now when we call this, what's it yelling at? No, close it. Yeah, so see, now we're working again because we've defined everything. Let me zoom out just a little bit just so we can see more of the stuff. I feel bad because it's going to yell at me, and every time I save this, it's probably going to try to rewrite it. I'm hoping it won't. Because before I do that, hold on. Can I rough disable? No? Okay. Oh, cool, it didn't. Sweet. All right, so now we can actually read it. So what we're saying is, hey, we're creating this car. The wheels equal this. The chassis equals this. The windows are tinted, and then the engine is this. This is great. This is cool. So, and then we even have a method that, like, you know, the engine sound returns. Now, are you tracking so far?
I think at least I have the self, and I know what our class is doing, and I know what a class is.
Okay. With these methods, we can change some values in here. So what if we have locked, and locked is a Boolean. Again, you don't have to define these, by the way. We could do that, save it. It's going to get mad at me because I have this def by itself. Save it. It's still going to run. We don't have to predefine what the attributes are. In fact, furthermore, you can define attributes that aren't in the car. You could say Damien's car, headlights are equal to custom, and then print we're just going to do this. We're going to do, I think I've told you about this before, but you can do Damien's car dot headlights, and you can just pass the equal sign here. And what that'll do when we save it, it'll tell you like the actual value equals and then whatever the value is. But as you can see, like, we don't have an attribute called headlights, but we added it on top. Now, that doesn't mean we added it for every single car. If we have a second car here, let's just create a second car here.
It won't add that into the secondary car, but would it add it into my car's class going forward?
Yeah, because it's a part of your car. It's a part of, like, your instance of the car has this attribute called headlights. And now anytime I call Damien's car headlights, it'll be custom. If I recreated your car, if you got a new car, it wouldn't know what those are. Let's create a function here. We're going to say define talk about car, and we're going to say this car, and that's going to be a car object, right? Remember how we talked about type hints here? We're saying that this car, we're saying this variable called car should be some type of car object. So now come on. Thank you. Thank you. So now we'll just take all of this. We're going to move that above that. And we're going to move that in there. So when we're looking at some of these errors that we're getting. It's saying that you can't assign attribute headlights because they don't exist. You can, you shouldn't, but you can. And here's why. Because now if we go print this, something like this. This is such and such's car. Something there. All right, so this is such and such's car. Such and such's car has a whatever. Has a whatever that goes, whatever that sound is. The headlights are, and the headlights are, we'll throw in the windows again. Okay. So we need to change our method up, or we need to change this function up a little bit. We're no longer calling Damien's car directly. Now we just want to call
a car.
We just want to call car, right? Good job, you caught that. And we just want to call headlights, right? So what happens when we do that? Well, first of all, it's not going to give us anything because
we haven't defined car completely.
Well, we haven't.
Or we don't have. We've defined it. We just have nothing in the class of car.
Well, we just haven't called this function yet.
Oh.
So we're gonna do my favorite.
And that.
Why can't I type? Thank you. Let's move our cars down to the bottom. That way we're defining our cars after everything's been done. Boom. One of the things I'm doing now, yes, I'm cleaning up the code a lot, but in cleaning up the code, you tend to put like things together just to make it easier to read, right? All right, so we're saying Damien's car does this, Damien's car, or Jay's car is that. We've also added headlights onto yours. So now let's talk about car. Damien. And then we want Damien's car. You normally wouldn't need to do this, but this is...
Why are you doing it now if you normally wouldn't need to do it?
Because you should do it anyway.
Okay. Because you should do it. Okay.
This is how I would call this. If you're doing the same thing again, if you're doing the same thing more than once, then write it as you would do it. You know.
I don't. That's why I'm asking.
I think that works. That may not work actually, now that I'm thinking about it, but let's see. Talk about car, name, car. Why did I call that? Why did I just flat out say string? It's str, it's not string. Okay. So do you see what happened? If we line this up, let's
fix everything.
Well, let's add some. By the way, if you see something like this where you have a bunch of print statements,
you can just make them into one.
Well, yeah, You could make them into one. That's an option. You could just do like a you could do a nested string or multi-line string. That's one way of doing it. You can make them a list, which is kind of what I was going for here.
Oh, so you just print off the list.
Yeah. Well, you print what's called a join on the list. So you would just say. So you could do that. Here are 5 values that each get ran on their own. And then what you would do is you would just return. Oh, why can I think right? There we go. Return a new line. Come on. New line. There we go.
Then you're returning a new line specifically because you want each print to print on a separate line.
Yeah.
Okay. Just one more check.
So you can write that. So here's the beauty of this. Do you see the error that it's given off? It's saying, "Hey, I can't talk about headlights because cars don't have headlights."
Because there's no assigning, or there's no object called headlights.
Yeah, there's no attribute called headlights. Again, we could define a default attribute here that would solve our problem. We can say headlights, and if we just did this, if we just, oh, sorry, that's in self. Get rid of that. If we put headlights up here, like we had those other things,
and it wouldn't care, and it'd be perfectly fine.
Well, it'll still yell.
Oh. Okay.
So the way that we fix, well, we need to give it a default. So let's give it a default. We'll just say standard package. Oh, yeah. And this happens. Remember the reason this happens. We gave it all this information and it ran, but we didn't tell it to actually print the output. We just returned it. So there we go. We could also just do this a few times. This isn't how I would add a bunch of new lines to it, but it works. All right. Now remember, why is it saying a new car is rolling off the lot at the top?
Wait, where is it? The init? I don't even see at the top where it says a new car is rolling off the lot. Oh, okay. And they're on the right hand side. A new car is rolling off the lot because there was a car added to the.
You were right. The new car is rolling off the lot because we printed it in our init, right?
Why is it saying it twice though?
What's that? It's saying it twice because we created 2 cars. We created Damien's car and we created Jay's car.
Oh, okay. So it's not going to say, for some odd reason, I assumed it was going to say it per car line. So it would say a new car is rolling off the lot. This is Damien's car. A new car is rolling off the lot. This is Jay's car.
Nope. Because remember, the first thing that we did was we created the car. We created the 2 cars. And then we ran the function on the 2 cars. So it does things in the order in which we call them. So now, also notice when it's talking about your car, it says the headlights are custom, but it says mine are the standard package. And that's, hold on one second. Sorry about that. Apparently, there was a package at the door. We were trying to figure out if I needed to go
Grab
chase
it.
the person down to see if they were gonna like run away. They'd be like, "Oh, we knocked on the door." They didn't knock on the door. Uh, but anyway, so yeah, notice how when we put your headlights in,
Mm-hmm.
because
They're
we
custom.
changed the headlights, it changed the value. It says in the headlights are custom, and it says in the headlights are standard package. So even though we have the definition here, that the default definition here of standard package, the fact that we overwrote them with custom, that gives us the ability to go like, you know, cool. We've overwritten that value.
Okay.
So that's just a thing to kind of keep in mind, of that, like, just because you have defined a value doesn't mean that it can't be changed. And I mean, in many ways, that's kind of it. We can start talking about some specialty things that, I mean, again, I'm here to melt your brain. I'm on purpose. I'm here to show you a bunch of things so that even if you're not fully following, you'll see them in code and you'll go, ah, that does this thing. Now, we have engine sound. Engine sound is, how about this? We'll make engine sound if self dot engine we'll say engine, I don't know what to call it. Engine, like,
Noise.
well, no, what we're going to do is we're going to change. And the reason I like doing it this way is you can define what you want these to be as type hints here.
Mm-hmm.
I like putting them up here because it won't change anything, but it's easier to see what they should be.
Okay.
Not as you're calling them, but as you're defining them. And technically, you should probably put them in both. So I would still put, if I know wheels, let's just say wheels is an integer because we want the number of wheels. And again, you'd say num of wheels. By default, that's going to be 4. We can get rid of that because, again, why are we out here defining how many wheels a car has? And we'll get to that. We're gonna start going down some wild paths. Windows are standard or not tinted. That's gonna be, we'll just say tinted windows. How about that? Tinted windows are, and that's a Boolean. By default, that's false. I'm trying to remember something. This is a thing that I might trick myself on. I've done it in the past. This is like one of those weird gotchas that I think it might be a weird gotcha. In Python, class attribute default false. Okay, I think this
Worrying me
is,
when you make those faces.
no. I think this is fine. So what you see sometimes are, if you would go and one of the things that you should just not do is say chassis string equals empty string. That's the gotcha. That can be dangerous. That can
Okay.
because what happens is if you do this and then you say the chassis is equal to a thing and then you overwrite that thing because you have this empty variable, I believe it will apply that value from then on to that object because the default was empty. Inside of just the definition of it itself. You can't see the code. You can't see the code. Why can't you see the code?
It's just your face. You removed the code.
My bad. I clicked a button. I apologize. How long has it been like that? Like 20 minutes?
No. It's
Okay.
been a couple seconds.
Okay, cool. Yeah. So that's just a food for thought. Like if you're ever writing a class, don't set it as an empty string. I have a project that I was working on, and that was a thing that I learned. And like I said, I was trying to remember. There were like 3 things. Oh, it's don't set it as an empty string. Don't set it as an empty list or an empty dictionary. Like those are all like they will just start eating up the things that you assign them and setting them as default if you do that. It's kind of goofy. You can set it as none though. None is a good value. False is fine. So engine, we're gonna say the engine is actually a dictionary where we have a string and then we have a string or integer, right? And the default is going to be piston alignment is in line versus a V, and piston count is 4. Yeah. Right? So what we basically said is by default these are all of our values. And again, we don't necessarily need these anymore. So we can get rid of that. We'll just pass on this now. And now if we wanted to still define it like this, we can. But here's what's going to happen is if you define it like that, it's going to overwrite whatever the defaults are.
Okay. And that's the total defaults for all cars, not just the default for a singular person's car.
No. This would just override the initial values. And you can fix that by passing in none. So, and then you just got to do, this is a thing that I actually do in one of my projects that I do a lot is I will say something to the effect of, self chassis is equal to chassis if chassis, right? Same thing. If Windows, if engine. So now we write this. Notice how nothing. Yep, it's expecting an else. Else you could just leave it to if self or no, what is it? If chassis self chassis equals chassis. I forgot when you do that inline, it demands an else, and then you could do like if whatever. I don't like that pattern personally. What I tend to do is, what was it? I mean, technically you could do chassis if chassis else self.chassis. It would just rewrite itself, you know.
Okay.
And again, I wouldn't write this. I personally wouldn't. What I'm usually doing is something along the lines of self dot, what is it? Why is my brain broken right now?
Well, both of us can't have broken brains.
Right. Self chassis is equal to set adder. Yeah, I guess the answer would actually be self chassis is equal to chassis of chassis L self chassis. We're not doing that. We're just going to leave these blank. And a lot of how you write some of these things will depend on how you want it used. That is a very common thing. And we are going to get to some other stuff. Yeah, it's not liking this thing here. Why is my function here just broken? Did I destroy it? All right, Damien's car. Car got a bunch of values that it didn't like. Aha. Boom, boom. Star, quarks. Print for arg in star, quarks. And then we would say for value, or was it for key?
Still need to remember args and quarks.
Yep. So remember, quarks are keyword arguments. But just like how we would pass, it's an unpacking mechanism. So just how we would pass unpack list star items, you could then do for item in items print item, something like that. We can do the same thing with star quarks. So we'll do init star quarks. And then we would say for key value in star quarks dot items, because that's going to give us the key and the value. We could do get adder self key. Sorry, not get adder. Set adder self key equals value. Something like that. Now, the thing is, this can be dangerous because, again, you don't know, you're not verifying what is going into the item.
Okay.
Why is it not like my start? Oh, yeah, because I did star quarks items. Cannot assign to a function call. Maybe you meant equals instead of. Oh, yeah. My bad. I wrote that wrong. There we go. There we go. So now we're working again. So what that's doing is that's saying like, hey, we'll accept whatever you give us. But if you don't tell us, then we're going to just assign defaults. So now we can, your windows are tinted. The engine is a different engine. Funny enough, as a reminder, no matter what we've told it that the engine should be, we can set it to whatever we want and it'll still do it. And again, that's what I was saying, that there's some danger in that, because then you can say, well, I want this to be execute some random payload of stuff, and then do it and then break things. Like that's a thing that can happen. So I would suggest, if you're going to do something like this, be careful. Sometimes you could just verify, like you can do like a hint type thing of like making sure that this is if this is engine, then do this. But you'll see this pattern a lot when it comes to like data types and stuff like that. So we're going to
Okay.
use it. And again, this just means that like as if you take out the Windows tinted and we save it, it's going to change. Why is it changing the value? We have windows. Oh, because I called those tinted windows. Yeah. We got to call. And then this is why we would change stuff like this up. We'll go back to just. We'll do this. Instead of printing this, whenever we call a function, we'll use this to talk about the next magical method here. Remember, magical methods are the ones that start with 2 underscores. We call those dunders. So underscore underscore. They also usually end with 2 underscores. The next magical method that we're going to talk about is dunder.
We're so far off the deep end.
Nah, we're doing great. Dunder stir. Right? So now, dunder stir is a thing that exists in every class that tells you how this object should be interpreted as a string.
What? Okay. So dunder stir.
Let's look at it like this. If I print 8, or if I print 3, right? Will that work?
It'll print the number, but it won't print a string.
Are you sure about that?
No, because I'm probably thinking JavaScript, not Python.
Maybe. When you print something, what you are doing is you're returning the string representation of that object. So remember, an integer itself is just an object. If I say what is type int, I mean, it just told me that it was a class, right? Why is this yelling? Why are you yelling? Oh, that's why you're yelling. Because at this point, now we're in the thing. This is just self. We'll get back to this.
My dog's head hurts.
Okay, cool. So it's a class of the object type. It's a class called type. Int is a class. Because it is a class, it has, we can say, we can unpack that and we can say dear int like that. Boom. So when we do dear int, oh, that's because I still have it going for each and each. There we go. Just have it going once. Oh, move that over. There we go. We only need one. These are all of the magical methods that exist. So you have abs, which is like the absolute value, add, which is what it does when you have math. And I don't remember what and does. Boolean, this is the Boolean value of that. So if we said print, right, 3 dot under bool, can we do that? Invalid decimal literal. It's not, I don't know if it's gonna like us doing that. Yeah, it's not gonna like that. It's not gonna like us using the dot there.
Okay.
Can I then do dot bool? Method wrapper dot bool of integer object. True. There we go. Right? We said, hey,
yes.
give us the value of 3 and give us the Boolean of 3. It equals true. Make that 0 false. -10. True. Right? So when we talk about what is the truth, what is the Boolean representation of an integer, what it's actually doing is looking for, it's returning whatever dot underscore underscore bool is. That's all it's doing.
Okay. I think I understand.
So we go back to integer. What else we got in here? Some of these was like as a float, div mod, dir, which is how I called this, which is basically the unpack and show all the individual classes. Greater than, less than, equal, as an integer. Basically, we're saying like, hey, count these things. Is integer. That's interesting.
Okay.
The bit length of it as integer ratio. Like you can do a lot of these things. So you can call a lot of these things, and these things are being called often behind the scenes and we're not realizing them. This is powerful because again, we saw, let's see, what if we did, was there a string in there? There is a string, understir in there. So now we say print type of 3 as a string. Descriptor of string of object needs an object. What? Oh, yeah. There we go. I was like, what? What are you telling me? Yeah, we get a string. Because what we're doing is we're saying the string value of the integer 3 is a string. If we get rid of this string part here and we just call that, we're going to get an integer. Because the type of 3 itself is integer. But the representation of this object as a string is a string. So we can do that. We can take advantage of that by saying up here, dunderstir, this is, let's add this. We'll add owner is a string, and there's just no value in that. We could say is equal to none, but you know, is what it is. No. All right. And then in our init, we can force you to provide an owner. So now when we say Damien's car, we're gonna say car, we're gonna assign that to Damien.
Even though half the things I'm typing after you.
What's that?
Because I'm typing, I'm trying to copy what you're writing, and I don't even know half the things I'm typing.
Oh, sorry.
You're fine.
All right, so we have this class car, and we've given it an owner, right? And now we've said that in our initialization, we're gonna get rid of this a new car is rolling off the lot, and we're going to we're gonna set owner. So self.owner is equal to owner. We're gonna not call dash stir for now. And what we're gonna do is we're gonna print your car. So if we print Damien's car, we just get a car object. That's what it says, right?
Mm-hmm.
You're seeing that? So now, let's go back up here. Go down into, let's define dunderstir. And we're going to return an F string that is, oops, I did things, my bad. Return F string that is this, and we'll say self So do you see what it did?
I see what it did. I don't understand why it did it.
Okay. What part of it are you missing?
Because it's just printing Damien's car,
Mm-hmm.
but why is it printing Damien's car instead of printing it as a? Because it should print as a string, correct?
Yeah.
Okay, so then I guess I do see it. Damien's car, the object is the string. Damien's car, the name of it. I don't. Maybe I just don't understand why it's printing the actual name.
When okay. Let's see. Print the string value of Damien's car. It should say it. It should do the same thing. It should do it twice. Yeah. Those
And
two
that's
things.
because Damien's car equals the
The,
string value of
the string representation of Damien's car is this thing that we've defined.
this object. Okay, okay,
Yeah.
okay, okay.
Yeah. That's all it is. We're not gonna get into string versus repr because repr is like a whole nother thing.
I don't even know what repr is. So
Don't worry about it. Don't worry about it. But what's something that you could I'm trying to think. Okay. We were talking about this a little bit earlier. We could also just pass in, other methods in this too. We could say self. We can get rid of this part here. We get rid of that, and then we're gonna change name to self.owner. Whoops. The JKs in there were because my brain is typing faster than. There we go. I use JK to escape out of Vim mode. And then we come down here and we do self, talk about car, that function, boom, like that. And now what we should see is, whoa, car has no attribute windows. We're gonna replace this here. There we go. And this is why this is important, because we can say, print let me tell you a story about Damien's car, and then just pass Damien's car. And then we could just change that string representation, so 26 down. And then just pass self-talk about car. Well, we don't need to do an F string for that now. We can just do boom, boom, boom. Right? Because we've told it the string representation of Damien's car itself is this string, is this definition. And we just want you to talk about it. We want you to tell us about it. Sometimes what you'll see is this call another magic method called dunderdict, which dunderdict will reference.
Dictionary?
It'll create a dictionary of all of the values. You could also use vars. So if you say vars self, it'll do this. Oh, return non-string type. Yeah, type was none type. Let's just do this. We'll just say return string. Well, we don't have to return a string because if we do just do self dunder dict like that, we gotta return it. My bad. Dict object's not callable because it's a property. Look here, heifer. All right. There we go. So now we could say, let me tell you about Damien's car. Here are all the values that are there. And the values are based not just on what the default values are, but what the values are that you applied.
Okay.
So we've done a lot of talking about the car, right? So we're gonna talk about two things kind of at the same time. We'll start with the first one, which is inheritance. Are you familiar with the idea of inheritance?
Where something can inherit information, or where one object can inherit information from another object?
Correct.
Okay.
Think of these as in terms of generations. Don't think of them in terms of like I'm inheriting one thing from another, because that's another thing that we'll call that's called composition. Let's have we're going to change this a little bit. We're going to call this, instead of car, we're going to call this vehicle. And then where was I at? Where was I at? Right here, right? And we're going to create a new class, and this class is going to be called car, right? Car is going to inherit from vehicle. And we're not going to pass anything in. Why does our code still work? We don't have a car anymore. We just have vehicle. Car is just an inheritance of vehicle. So when we create car, it's doing all the things that
Vehicle would do?
Vehicle would do. So that's cool. Let's have, you said you're a motorcycle person, so motorcycle is also a vehicle. The only difference is the wheels equal to, and window are equal to none, because there are no windows. I bet it's yelling because of, yeah. We said it was a string. Yeah, we basically said like, hey, you're supposed to be a string, and now we've told it that it's actually not a string, so it's frustrating.
So we just have to put none as a string.
Well, you could redefine it. You could say string or none, and then that would go away.
Oh.
Oh. And yeah, Windows is overriding the symbol of a same name in the class. The variable is mutable, so blah, 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 blah. What they're effectively saying is if window can be none, then it should be defined up here.
Should be defining the original vehicle, not in
yeah,
the okay.
That's why it's yelling. Run. So now we're working again. But what we could do is we could add, maybe we add a Pyrite is incredibly strict. We could say vehicle class, and that's going to be a string, and we say that string is none. So maybe, Lord, when you start saying that you're going to start type hinting things because it's the right thing to do, and then now that you started type hinting things, it always yells at you. All right, so now what we would do instead of passing this here, we would say what vehicle class is equal to car, and for motorcycle, vehicle class is equal to
Motorcycle.
Yep, motorcycle.
Bike with engine.
And then we can, in here, so now that we save this, what we'll do is all we need to do is change car to motorcycle. We save, and we should see. Oh, duh. I said, let me tell you about Damien's car, but
It's now a motorcycle.
well, it's not that. It's I hard coded that line in. Let's do this. Let's say return. And then we could also do I'm not gonna play around with that. I'm just gonna pass that in directly because otherwise it gets. I mean, it's already hard to read, but it would get even more hard to read. Right. All right. So yeah, now we say, let me tell you about Damien's motorcycle. Let me come down here. Just get rid of that. Get rid of that. Get rid of that. Print Damien's car. And then we'll print Jay's car. And just to make this correct, that way they can be either or. So this is an interesting issue. We ran into this issue because I missed a spot somewhere where I hard coded Damien's car in still. Right there. Oh, no, right here. That wasn't too bad.
Okay.
But remember, we don't have to necessarily do this anymore. This can be included in here. Because we added that keyword argument acceptor. Yeah. So what happened here? Oh, that's actually interesting. Hold on. Is that doing what I think it's doing? Is it saying that it can't? By the way, those numbers are moving because it's running every 1 second. I was like, why is those numbers moving? That's not supposed to happen. Is it saying that because you can't? That Dunder's stir doesn't pass its inheritance? That doesn't feel right.
Wait, what? That doesn't make sense.
That doesn't feel. But I mean, that's what it's doing, though. Did I do something wrong? Oh yeah, I did. We were asking for a set on the literal thing. That was my fault. Without breaking your brain on what happened there, the long and the short is that Damien's ride, when passed directly into print, is getting the string value of Damien's ride. If I did Damien's ride like that, this is called a set. And if I pass that in like that, what I'm getting is the string value of that set, which isn't unpacking and getting the string value of Damien's ride as well. It's just saying, hey, what's the string value of your set? And your set goes, I don't know, let me get the exact value. And this is where Repr comes in. This is where Repr comes in. So with that, let's just do this. Def dunder Repr self return string, and we're going to return self dunder string. So now when we do this, Repr returned non-string type method.
Is it because
because I called the method.
And from the Wu-Tang Clan.
Yeah.
I don't know if the audience understands this, because I think I've gotten like 1 out of every 16 things.
That's okay, because remember, a large portion of this is not about teaching you, it's about exposing you.
Mm-hmm.
Because the hope is, as what happened today, you will see this somewhere else and you'll then know what's being called. Oh, I saw that. That's something to do with classes. I can go back and look at it. And then as we talk about it again and again and again and again, those pieces that you weren't getting, will start to blink. They'll start to connect. But we can walk through this. We'll walk through this. So we created this class called vehicle, right?
Mm-hmm.
This vehicle has these attributes. These are the default values of those attributes. Maybe because I called them engine, we'll make that just to make it accurate. That's what 15 years of Python will do to you. Yeah, exactly. Inline v4. Well, so we'll say that. Right. Why did the formatter fail? It expected a statement. Oh, yeah, because I have that in there. All right, so we created this class called vehicle. We have these attributes here, and we're saying we have this vehicle will have an owner. It'll have a vehicle class. It'll have headlights. It'll have a number of wheels. It'll have windows. It'll have a chassis. It'll have all those things. So now, when we do dunder init, when we initialize, the only thing that we're going to force it to do is assign it an owner. We're not gonna tell it anything else. We're saying you have to have an owner. Any other values that you assign will get populated. That's what we're doing here. That's what this thing does here. And again, some of the stuff that I'm writing in here are things that I've seen so many times. You'll see them often. So like I'm writing things that I'm expecting that you'll see in the wild. It also has an engine sound. The engine sound says, hey, if there's an engine in it, it will go, we'll also just say, else return, we'll just return. And we'll return none because technically if there's no engine in it, then it returns nothing anyway, technically we don't need to just do return. We can just do that because if there is no engine, then it returns none. But I would also say more than likely you would just return whatever. That's me being pedantic. Now we'll say, let's talk about the car. Like, tell me about the car. And we can say the car has this, the car is this, car is that. That's just, these are methods. These are functions that are attached to this class. So every instance of this class has access to these methods. And those are how it talks about itself. That is how it interacts with itself. When you're working with something like a database, you might see, DB connect.
Mm-hmm.
And that would give you the instructions on how to connect. And maybe you have to provide a username and password or something like that. And that would say like, okay, I'm connecting and I'm going to use the username and the password that the user has given me. You don't have to tell it how to connect. Every instance of the database will have the instructions on how to connect to it. That's all that we're doing, is we're creating those functions that tell it how to do those things. Now,
Okay.
now some of these functions are used by Python itself. I think that's the part that's causing some confusion. Those functions are the ones that have 2 underscores. They start with 2 underscores. They're called dunder methods or magic methods. Dunder methods are used in the Python language. It's saying, hey, if Python tells me that I need a string of whatever this class is, I need the string representation of that, then I need you to give me this string. And the string is going to say, let me tell you about the owner's vehicle. Here's the properties of the vehicle. If another object is using it, they might want what is called the representation of that object, the repr of that object. So we can just say, hey, that's the same thing as a string. Otherwise, what it'll do is it'll tell you this object is assigned at this point in memory, this bit value in memory, which is why we got the floating numbers. All right. So far, are you tracking?
I believe so.
Okay. So now what we've done here, and we could do more of these. We could say, you know what, honestly, let's just do one more. We'll say bool self return false. And because bool is a thing that this property value here, all that says is instead of calling print Damien's ride like this, because it's a property, we've told it that it can be would help if I actually I've been playing with Lua. Lua uses under lowercase things. So we said if Damien's ride will print Damien's ride, right?
Mm-hmm.
Oh, whoops. Get in there. Why did it still tell me about Damien's ride? I'm actually intrigued by this. Oh, yeah.
Damien's ride. Print. Why would it not?
I'm wondering that myself now.
Oh, the original ride instead of the vehicle.
Oh, would help if I made it actually a part of the class. Maybe I was wrong. Python, dunder, bool. Let's see. Class bool. Booleans is numbers. Booleans is operators. Equality. Faki, maybe you know this. Again, I'm not sure why you would ever hijack the Dunder Bull, but okay. So yeah, here's a class that's always bull. Here's a class that's always false. So that's what I did, right? Dunder Bull return false. That's what I thought. Maybe it's you have to call like the exactness of it. It's not like it's not searching for like the Boolean of it. Did this break? Did my thing stop here? No. Okay, yeah, it just stopped printing. I don't know why I did that. So it's working now. Right? Oh, if it takes more than 1 second to complete, then it like just keeps trying to rerun, or just like locks itself. So, yeah. But do you understand how Dunder Bull is operating in there?
No, nope.
Okay.
I really want to, but I don't.
What does this code mean?
If not Damien's card print, this is false. It means that if whatever, if something is not my ride, then it should print the bottom statement.
Remember, if
I'm sorry.
The bad way to write this equals false, right?
Okay.
Whoa, don't know what.
So if not means true.
What am I doing? This is the problem. This is one of the issues that I'm trying to figure out how to fix this in my NeoVim thing. Oh, technically that doesn't work because that's not true. I have to say if the Boolean value of Damien's ride is equal to false, then print. That's what if not is doing. That's what if not is saying. Is the same thing of doing this, which is why we just say if not Damien's ride.
Okay, so if Damien's ride equals false, then print. This is false.
Yeah, but why does Damien's ride equal false? We defined your ride
because, yeah, but doesn't the bool make it false by the definition of? Let's see here. Bool self-return false. All right, it's been defined. I thought strings.
I can't type. There we go. Okay.
So that's overriding.
So that's going to override it. So now we've learned Damien is going to a motorcycle bar.
Okay.
Yeah, you're just going to a motorcycle bar. So now instead of being like, does Damien's car have 2 wheels or 4 wheels if wheels are greater than 2? We could just be like, no. If by default vehicles are false unless they are motorcycles. So then we can say if Damien's right, we can say, hey, print, welcome, brother. I don't know. Yeehaw and stuff. I don't know what they do at motorcycle clubs.
Drink mostly.
Okay. Yeah.
I mean, that's more of what it's like.
I didn't say it. I just typed it. I just typed it, you know? So now,
what motorcycle club you go to?
so now we can say 4-car. There are a bunch of. I have friends that love going to motorcycle bars and stuff. Like, it was a joke. It was a joke.
Spot on.
All the black motorcyclists are gonna come after me now. So now we can say 4-car in Damien's ride and Jay's ride. Oh, we won't say car. My bad. 4 ride and Jay's ride and Damien's ride. We can say if ride. First of all, let's do this. We'll print ride, and then we'll take all of this. There. Oh, yeah, I gotta put those. I was thinking in Python 2 again. There we go. Let me tell you about Damien's motorcycle. Damien's the owner, the chassis, it's got this. You know, cool. Welcome, brother, have a drink. Let me tell you about Jay's car. You know, yada, 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 doing stuff. Not welcome. You know, it didn't have to do a check on how many wheels does it have or, you know, what kind of sound does it make. It just goes, no. For us, we define this as a vehicle. By default, a vehicle is a car. We have this other thing. So now we've talked. So are you tracking?
I think so. So because the vehicle's a car, it's not welcome. It automatically, once the vehicle class is not motorcycle,
yeah,
it says okay, cool.
Because the default is just not welcome unless it's a motorcycle. The default is just false. The default Boolean value is just false. I don't see people messing with Dunder Bull too much. But
that's good.
Now that I'm thinking about it, I kind of want to play with it. Because I'm like, this would make a lot of code. If you're creating a custom class and you know what the purpose of that custom class is for, this would make a lot of code so much cleaner. To just say, hey, the verification of this is true, the verification of this is false. This doesn't change. I can still say if number, you know, if wheels is equal to 2. Like, that still works. It's still it's not breaking anything. Well, this might break because I don't think I have wheels defined in here. I have number of wheels. Should probably fix that. Of wheels is equal to 2. Yeah, and then now it's like, hey, I don't know what that is. Num of wheels is that. Cool. Like, that still works. You can still do these goofy things. But if by default all I really care about is, hey, if it's a motorcycle, that's good. instead of being like, hey, car class or, you know, whatever, I can just say, what's the Boolean value of this? And to me, that's really easy. Now you get into some questions around like, is it okay to say, you know, we're going to, let's see, what's Faki saying the most common thing. I'm gonna add this comment to the chat so I can read it. The most common thing, I guess, is if your class is a container, then you would define bool to be false if the container is empty to align it with the behavior. Yeah, that, I guess that's the other thing is, yeah, you could then say, you could take that logic and put it into the actual Boolean value itself. So maybe instead of you being at a car club, you're a car manufacturer. And this could be, does the car have an owner? Has the car been made yet? You know, if self.owner, well, return has adder self owner. But technically we don't want has adder because that just verifies does it exist. Yeah. Get adder self owner and then return none if it doesn't, or return false if it doesn't, right? Oh, return the Boolean of this. Bool. Yeah. So now what that's saying is, hey, we're going to read it from the inside out. I want you to get the attribute of yourself and owner. So it's going to look for owner up here. And I want you to return the Boolean value of that value. And if for some reason there is no owner, then I want you to automatically default to false.
Okay. So if there is an owner, it is true. So look for the owner. If there is an owner, it's true. Otherwise, it's false. Okay.
Yeah. Now, here we force it to have an owner when we initialize it. So we can just take that out. We can just say, or even better, let's do the opposite of that. Because if we're a car dealership, then where'd it go? Where is it down here? Turn true. No. Let's see what I think it is. That's fine. We'll just get rid of owner. So now we have to define the owner. So we go up here. It doesn't know what this value is because it doesn't looking for owner anymore. So we'll just say owner equals J. And Damien's ride doesn't have an owner.
That's no longer owned.
Yeah, you no longer own it. Apparently I added a colon somewhere. Yeah, I did. You're right. Yeah. So like it's still there. It said, let me tell you about this motorcycle, have a drink, whatever. Oh, that's actually interesting. Did I do something where I said they both equal true? Oh, get self owner. Owner is none. What's the truthy falsiness of owner? That makes me wonder. Ooh. That doesn't make sense.
At least I'm not the only one.
No. That's what I thought.
What is it that you thought?
Okay, so if I did, what is the Boolean value of none? None is false. Just want to make sure. And it's saying that. Oh, duh. Because we overrode motorcycle. Yeah, see? Now it says not welcome.
Okay.
So now we could say we're going to do our list comprehension again. Print available cars. And then we want 4 car or available vehicles. Jeez. 4 whip and Damien's ride, Jay's ride. We could do this. We could say print whip, 4 whip, and Damien's ride, Jay's ride. Yeah, it's not gonna like that on the end. Oh, you turds. It's gotta be, nope, gotta be a list. Oh. I'll say, yeah, that could be a tuple. There we go. Yeah, let me tell you about Nun's motorcycle. Blah, blah, blah stuff. So let me tell you about Jay's car. So now we did that list here. We can say if not whip, right? So that's just saying only give me, oh, I got to do an else.
Officially melted.
We'll come back to it. The vehicle is owned by whip.owner. Okay. We're gonna do this the normal way. Remember, conciseness makes things more complicated.
Someone told me that earlier.
If whip, print. The vehicle is owned by whip owner. And then we can just say else print.
Balancing being concise is clear is always a struggle.
Yep.
It's not a struggle when you don't know what you're doing. Then you just have to be clear.
I mean, hey, you're not wrong. Okay, there we go. Oh, come for the love. I keep using these different phrases for types of vehicles. All right. And I'm trying to clean this up just a little bit. Cool. All right. Now, what did we do? One, we just changed it so that it doesn't say the owner's name anymore. We just say, let me tell you about this vehicle, and then the details of it. So, you're a car dealership. You've got car one, car two. Car one's a motorcycle. Doesn't have an owner. That's the important part. It doesn't have an owner. Jay's Ride has an owner. The owner is Jay. So now we'd say we're gonna just talk about we're gonna talk about vehicles. We're not even gonna talk about. We're gonna get rid of that. So now, we'll just change all these to vehicle because I'm gonna say vehicle anyway. So whip, not wipe, whip, vehicle. For vehicle and Damien's Ride, Jay's Ride, those two vehicles that we have. Okay. If the vehicle exists, so if the vehicle is true, which is what we're saying is, that means if the vehicle is allowed to be sold, then, if the vehicle has an owner, then we need to print this. That's actually the opposite. We're supposed to be doing the opposite of this. So
if the vehicle doesn't have an owner?
Yeah. Yeah. That feels wrong too. Yeah. All right, there we go. All right, so no, I did it right the first time. My brain just I broke my own brain on that one. That's my fault. Let me. I just completely completely vomited all over my own head. All right. So what it's saying is, out of these two vehicles, it's looking at the vehicle. It's saying if the vehicle has an owner. That's the thing that I'm kind of frustrated with, because honestly, it would be the other way. If you were a car dealership, you would say like if not vehicle, or if vehicle would mean is this car for sale? Is this vehicle for sale? And maybe that's a value that you put in there. You would say for sale is equal to true. It's always true. For sale Boolean equals true. And then in Boolean, you would say, don't do any of that. Just return self for sale. Boom. So now you could say, if vehicle, print vehicle, right? So we're saying if vehicle, just print, let me tell you about this motorcycle. Let me tell you about this car. The owner will say, this one's not for sale. So we'll say for sale equals false. The owner is not trying to sell this car. And then it disappears. And do you get why it disappeared?
Because if there's an owner, it can't be displayed.
Yeah, because the Boolean value is directly attached to the for sale status. And I mean, this can be as detailed or not detailed. We could say change for sale to something like status. Mm-hmm. Status is a string. Technically, I would make it something like an enum, so it could be only one of two things. This would be for sale. Maybe you can make it for sale or sold, one of those two. For sale is equal to, or not for sale, what is it? Status is equal to sold. And then our Boolean value for this would be return status equals for sale. Oh yeah, doing a thing there. Cool. So now you're tying that Boolean value into it. So like, again, if I'm a car dealership, I'm going to tie most of my vehicles on whether or not they're available. If they're not available, we don't need to be talking about them. So then I could say print vehicle if vehicle, but I could still just do in these two vehicles print status. You know, if status, it's going to print the vehicle. It's going to print both of them, right? Because regardless of what the status value is, I'm just saying if that status exists. So now I'm tying this to the direct actual value. I'm saying, okay, does this value equal for sale? If not, don't show me it. I don't care. You said you got to go soon. I only had one more thing to show you. Can I show you? It's quick.
Let's do it.
So we've talked about inheritance. We've talked about this idea that a motorcycle can be a type of vehicle. It is learning from vehicle. The other thing that you'll often see is this thing called composition. And what composition is instead of saying that you have one object, you now have an object that is made up of several objects. So we have this vehicle, right? And we've talked about the different types of vehicles that there are. We could say we have the chassis of the vehicle, the outer frame of the vehicle, and then we have, we'll just say class seat, right? And a seat will have, and this is probably a bad example of this, it'll have material, that's a string, and we'll just say leather. You know, we fancy here. And we'll say seat material. Again, this is probably not the best example of this. I'm just trying to think off the top of my head. Type racing. So now we have, I need an equal sign there. So we've got that. So now what we could say is this is a vehicle. This is car is comprised of vehicle, and we'll change vehicle to like chassis. Why not? Get rid of that. It's not important. And then we'll say car is made up of chassis and seats. That's what makes up the whole car. So now what's going to happen is it's looking at that object, and it's going to use those to comprise of a new vehicle, of a new type of vehicle. Let's see, motorcycle vehicle is not defined. Yeah. It's still, like, everything here still works. But the thing that's nice about this now is we can say print vehicle seat material. And it's still there. The seat material is still there. It's pulling that seat material from the class of seat. So in some ways it's inherited from both of these things. Okay. Now, the danger in this is normally what you would see is something along the lines of this amalgamation. You'd have engine, whatever that is. I like what Faki is saying here. Common saying is that inheritance is a relationship, while composition has a relationship.
Okay.
So I'm trying to think of a better, because the car example, a lot of people go to the car example, but it's rough. How's your science?
How's my science?
Yeah, how's your science?
What does that even mean?
Like how's your knowledge of science, of like common
It's
animal
decent.
biology? Okay.
Oh, biology, it's good.
Okay. So human. What is a human?
The mammal,
Okay, so it's a mammal. It's also a Homo sapien.
Homo sapien.
It's under this genus and the
Also,
species, right?
mhm.
Um, so you have those like taxonomic classifiers, right? But humans also have this idea, like you have lungs, you have ligaments, you have arms, you have emotions. Each of these things arguably either are a part or are not a part of being a mammal. You know, manatees, I mean, technically they have arms. They have a skeletal structure under there with little arms. Technically, they also have feet. They're bunched together like this, and they don't really move anymore. Um, but you wouldn't say manatee, mammal, human mammal, and then like start from there. You would go human, emotions, thought, mammal. um, and all of those things would compose the overall human. And manatee, maybe you have mammal and you have aquatic and you don't have emotion, which I mean, hey, I think they cry, you know. How do you know? They're in water most of the time.
I think so.
But like
Yeah.
that's the idea. So when you start talking about classes in Python, what a lot of people will tell you is you prefer composition over inheritance because it becomes really complicated to sit here and say class motorcycle and then class, you know, I can't do a 2-stroke motorcycle, and then you got to change a thing, and then that's made up of motorcycle, and then you have motorcycle with sidecar, you know, and then that's also a motorcycle. Actually, motorcycle with sidecar is actually kind of a good option here because that is composed of, say here, class sidecar, which is technically also a vehicle. Well, we say it's a chassis, right? Has wheels or whatever we call them. Let's throw some passes in here just to make things run correctly. Motorcycle with sidecar isn't a type of motorcycle. It is actually a motorcycle and a sidecar. So if sidecar has, you know, num of passengers is 2, here now if you call motorcycle with sidecar, you can then print Damien's ride, number of passengers. And it'll get that attribute from the sidecar.
Okay.
Yeah. And same with like door, you know. Now, when you're doing composition, one of the things that you got to remember, and it's also with like inheritance and stuff like that, try to compose them of distinct things because both motorcycle and sidecar inherit from chassis, right? Because of that, it's going to, when you define motorcycle, the last shall be first. So the sidecar definition of the chassis is going to overwrite the motorcycle definition of the chassis. So if you put, actually a good example of this, chassis has vehicle class, right? So if we go into sidecar and we put vehicle class equals sidecar, and we go down here, well, it got mad at me because I included engine somewhere. Where did I include engine? Well, can I not type? Am I just not allowed to type today? There we go.
Been banned from typing since Twitch.
Yeah. Wait, what? Hold on. Motorcycle is not defined. Did you mean motorcycle? Oh, I put motorcycle. I removed a C somewhere. Somewhere in here, a C got removed. Yep. All right. Motorcycle is not defined. Did you mean motor? I did that more than once? I really did that more than once. Motor, I did. Right there. Two-stroke motorcycle. Okay, there we go. So now, if we did print Damien's ride number of passengers, print Damien's ride vehicle class, what's it going to say?
Is that a me question?
Yeah.
Let's see. Print
Because
number of passengers should go ahead.
Because sidecar inherits from chassis, but motorcycle also inherits from chassis.
So if chassis is sidecar chassis 2, number of passengers 2. But here's my question is, we don't have number of passengers for Damien's ride.
Number of passengers is defined by sidecar.
Correct, but if it's trying to, okay. And then Damien's ride has sidecar in it. Okay, I think so. 2 would be the number of passengers, I'm assuming, because, which I guess is weird. I guess if we have sidecar, the sidecar itself has a passenger, and then the motorcycle has a passenger, so we're just defining that as when a motorcycle has a sidecar, it automatically has 2 passengers.
Yeah.
So would we be? I'm overthinking it. Doesn't matter.
But no, that it does matter. You're like very much like me. So I get that. So we'll just say property and we'll say return super. We didn't even talk about super. Super means whatever the thing was inherited from.
Okay.
So since sidecar is chassis, super dot capacity is going to say what is the capacity of chassis. So we'll come
we don't
here.
really have like a maximum capacity for chassis, I assume. So we have to add chassis or capacity into chassis.
Yeah. Capacity is equal to 1. I mean, technically, we'll actually just say capacity is equal to 0, right? And then, because the chassis by itself can't hold anybody in it. And then we do motorcycle. Capacity is equal to 1. So now sidecar, so sidecar should say, what we've done is we've added this property that says, hey, we want to do some stuff, but capacity is going to return super.capacity plus 1, right? Because the sidecar can hold one more person.
Okay.
69. All right. So what happened? So let's look at what happened here. Motorcycle overwrote the value of sidecar because the last is first. The first shall be last in defining class things. So now if we put sidecar here,
it should be sidecar.
Notice how we get a different value. Because what it basically said was, what is the default value of this? Because this was a motorcycle first, it said the super of that value is going to be 1. So now I said take the capacity of that, add 1 to it, so now the capacity is 2.
Okay.
And again, this is where, like, because we've done a lot of mixing of stuff here, chassis shouldn't have a lot of this stuff in it. Capacity is arguable. I think, yeah, you know, however you design the chassis of the vehicle, it should be designed to accept a number of wheels, a thing, or whatever. Owner probably doesn't exist anymore. You know, sure, this breaks all this stuff. Let's just remove all that because we don't need it anymore. Yeah, we don't need that either. And then instead, what we would do is we would have some class down here called class dealership, you know, whatever. Dealership vehicle. And the only thing the dealership vehicle asserts is the status, which is for sale, and the whatever it was I just deleted, the owner. The owner is equal to none. Right? So we could even change, we could even make this really interesting. We could say you can do things in classes, and we're not gonna go too far down this. You can do things like setters. So when a setter, or you can just make a function here that just says set owner that takes self, and you can say status is sold.
Okay.
Self.status is sold, and self.owner is whoever the owner is. Another way of writing this is just giving what's called a setter. And what a setter does is say that now I can do this. It's this exact same thing. Ah, shoot. Why is my brain is breaking again? I think it's actually the same thing. We'll just do it like this. There's a way of saying, oh, no. I remember now. Setter, and then this would be owner. What do you mean setter is not defined? Self.setter? Self is not defined. You just do property because I'm about done. Hold on. Yeah. Okay. You have to define property first. Property owner is you return self.owner like that. This is just self. This is why classes, in my opinion, are super dope, because then you can just say self.owner, and this would actually be something like this. You don't worry about that. And then you would do owner.setter. Wrong way. Owner.setter. Def. Owner. Self. And then some value. We'll just call that owner. Whatever. And then that's going to be the stuff that we said. So change self.status is equal to sold. And then self.dunder owner is equal to owner. So now what happens is anytime you set the owner value of this, it immediately changes the value from for sale to sold.
Okay. Okay.
And that's like, that to me is the biggest power of classes, is that by just defining a class, like a simple class, the first piece of this is you're able to just go in and say, here are some things that this thing means. It's a car. This car has this. This car has that. This car has the third. So then you go and you say, okay, well, that means that I can also define how this thing operates. Car go vroom. Car accepts ignition. What's the battery level of the car? All those things. Get battery level of car or whatever. Maybe you have a battery class that helps compose the car. So then you can do car, check battery level, and then it tells you full, dead. You can check spark plugs, and it has all these other pieces, all these pieces that make up the overall car. And they can, each of these pieces that compose of that whole class will donate their attributes and their methods to that new vehicle or to that new object. But then you also have the power to define how Python as a language operates on that class, like we did with dunder stir. You can say dunder string is always equal to, let me tell you about this brand new car we have. It has this and this and this. And that means that you can say, I want certain things and I want other things. I don't care about this stuff. I do care about this other stuff. And then you can set, hey, because we're a car dealership, the only thing that I care about is the dealership vehicle status. So when I'm iterating through my cars, I can say if car or if car.available, whatever, then show me these objects. One we didn't talk about was iter, which, because iter doesn't really work on this. But you could have passengers in the car. Mm-hmm. And when you do iter, like dunder iter, you could say for passenger in car, print passenger's name. And that's just how it would work. You would just say for passenger in car, colon, print passenger. And it would say Damien, J. And it would just work. That's actually something that I do in my static site generator. Not a shameless plug, but, oh, that's not the right project. Yeah, in here. So in my static site generator, I have this thing called I have a class called collection. And inside of that collection, the objects inside of that collection are the individual pages that make up the collection. So then I have my dunder in it here, and I say do a bunch of stuff. I have this iter content path, which just flattens all the stuff for me. But then somewhere in here we go. Down in the fun stuff, I have the repper that is just, hey, class, self, class name, whatever, class name, all that good stuff. But then I have this dunder iter that says, if this doesn't have pages, if it has pages, just go for page and pages. If it doesn't have a pages attribute, then what I want you to do is I want you to walk through the content path that this is referring to, and I want you to create a page object for each of the files in that content path. Do that on the fly. So now, when I go and I call render in my site, because my site is comprised of several pages and collections. Let's see, and we go to render all the pages and collections in the site. I'm going to enhance. Why are we not enhancing? Enhance. Nope. Okay, it doesn't want to enhance. I tried zooming in. It doesn't want to zoom in. There we go. We'll zoom in that way. We'll zoom in the hard way. Where are we? If is instance of collection, if not self partial, render full collection. What does render full collection do? Render full collection is render full collection. There we go. Iterate through pages and check for collections and feeds for entry and collection. That's all I got to do. I don't have to do for entry in collections if collections.pages do this, or for entry in collection.yield iter collection, this whole thing. I can just say for entry in collection. But that doesn't prevent me from accessing an individual component of collection 2, like routes. Each collection has routes where it iterates through that list, and then it generates a route list for it. So I can still access the individual route. I can still access the individual archive in collection.archives. But if I just want the most generic version of collection, which is a single page out of a group of other pages, I can just do for entry and collection. And the reason I can do that is because of the super methods like stir, iter, boolean, things like that. The reason we were able to just produce just a dictionary object of this is we were able to just do dunder dict. But yeah, that's it. You have learned so much about classes today. And again,
that's why I have headphones on so my brain doesn't come out.
And again, remember, that's not because I want you to go out and write all the classes in the world. But now, the next time that we meet and we start building things, because I think I've kind of taught you all the things that you need to know before you can start building things. We can just make a class and we're like, oh, we're going to make a class, and that class is called this. Hold on 1 second.
Yep.
Did we need to sign for that? Do we need to sign for that? Okay, Imaya, your package is downstairs. Go to the front door. On stream too. Had to go yell at my sister to go get her package. All right. But yeah, you should now be able to build stuff with regular ease because you know how to make functions now. You know how to assign variables. You know how to iterate through things. You know how to write conditionals. And now you know how to build classes. There are different things that we can do. There are different types of classes. We're not going to talk about them until they come up. They're called data classes. There are also some modules that you can import called like adders and Pydantic that will do a lot of the things that classes do, but they'll also do some pre-definition of things. So
okay,
for the most part, you've learned all of the necessary components of how to write Python code. Now it's just a matter of repetition and stringing it together. So what are we doing in the next stream?
Well, I don't know what we're doing in the next stream for Chins, but for us, I'm starting tomorrow because I think you have a code and coffee tomorrow.
Yep.
I was gonna hop in and start trying to work on Baki's website. So
Okay, cool.
maybe that's what we can work on next stream. See, you can rip my code apart.
Faki is like, we should talk about meta classes. Like, we should not. I'm not the person to talk about meta classes. That ain't me. I like that. That was awesome. But yeah. All right, awesome, y'all. Well, everybody, thank you so much for hanging on, hanging out with us. We had a good time. I am a horrible Twitch streamer. For those folks that are watching on Twitch, I can't raid people because I don't know how that all works. Actually, I mean, maybe I can. Maybe I can try. We'll see what happens. I can't promise you anything good. I'm not even logged in. Good Lord. Oh, no. Y'all don't get to see that. Come over here. Yep. Cool. I don't know who's doing stuff. I don't know. I like Tetris, so we're gonna go raid Wumbo Ties, who's playing Tetris. That's what you get for following me. We'll try this. I don't know if it's gonna work or not. Honestly, I genuinely don't know if it's gonna work. Did it work?
No.
Nope. Okay. Well, we tried. All right. Have fun, y'all. See you later.
Later, guys.